In this lesson, we're going to start with the beginning of trig, so SOHCAHTOA, and then we're also going to go more in detail about special right triangles and how to graph with them. Okay, so trig is the study of the relationships among the angles and sides of a right triangle. So when we do it, we are looking at SOHCAHTOA. Okay, in SOHCAHTOA, the S is going to be the sine, the C is going to be cosine, and the T is going to be tangent. The two letters that follow after it are opposite, hypotenuse, or adjacent. So we always pick an angle that we're going to look at it from. Okay, so we're going to look at this one from theta. So generally it's the given one. You never choose the right angle. Okay, across from your right angle will always be your H or your hypotenuse. Then my opposite, zoom in here. Okay, the opposite will sit opposite. Okay, this was my hypotenuse. Okay, and then adjacent is going to be the other side sitting next to it. Okay, so when I do my sine, I look at my SOHCAHTOA. It goes O then H, so my O then my H, or my opposite and my hypotenuse. Okay, cosine is A then H, so then we have A then H, or adjacent then hypotenuse. Tangent is O then A, so O over A, or opposite over adjacent. So we're going to use these to find missing sides and missing angles in right triangles. Okay, so my first step, we need to use Pythagorean theorem to find the missing side of a right triangle. Remember, across from your right angle is always going to be C, so I'm going to pick my A is in missing. Your A and B, it does not matter, but your C always has to be the correct C, so that one across from your right angle. If we wanted to solve this so that all we have to really do is plug it in our calculator, we would subtract 5 squared. Opposite of squaring is square rooting, so that is what we would type in our calculator, and we would get 12, so that's going to be my missing side there. Okay, so I went ahead and wrote in my sine, cosine, and tangent that we're going to find, and my SOHCAHTOA. So my SOHCAHTOA, we need to make sure we label all my sides here so that it's easier to find my sine, cosine, and tangent. Okay, so across my right angle will always be my hypotenuse. We're looking at this one from theta, so my opposite that sits across from it, or opposite of it, is going to be that 5, and adjacent is going to be that other side. So sine is O then H. My O stands for 5, and then my H stands for 13. If you can simplify your fractions, do it. There should be no decimals. If there's a square root on the bottom, you can type it in your calculator and have it simplify it for you, but you cannot have square roots in the bottom. Okay, cosine is A then H, so A stands for 12, and my H stands for 13. Tangent is O then A, right in there, so I got my O, which is 5, and my A, which is 12. Okay, so we got to find our missing side, so we could have it B be the one missing this time, because across from my right angle is that 9, so I would subtract 7 squared. Opposite of squaring is square rooting, so that right side is what I'm typing in to find my missing side, which gets me 4 square root 2. So we're looking at it from theta, so my H is 9, my opposite of it is that 4 square root 2, and my adjacent is that 7. So I'm going to write out my SOHCAHTOA, my sine, cosine, and tangent. Okay, so first my sine is O then H. My O stands for 4 square root 2, and my H stands for 9. So I have 4 square root 2 over 9. My cosine is A then H, so my A stands for 7, my H is 9. And my last one is O then A, so my O stands for 4 square root 2, and my A stands for 7. And it doesn't look like any of those fractions can be simplified. If you're not sure, just type it into your calculator and see if it simplifies it for you. Okay? These special right triangles, you're going to have to memorize for the test. For 30, 60, 90s, across from 30 will always be x, across from 60 will always be x square root 3, and across from my right angle will always be 2x. Okay, your biggest angle is your 90-degree angle. If I multiply something times 2 here, it will be my biggest side, which is why the 2x sits across from 90. Your medium length, or your medium degree, is 60. which sits across from x square root 3, which is also the medium length. If I multiply something times the square root of 3, it's going to be less than 2, but more than just having an x, which is sitting across from your smallest angle. The easier one to remember is the 45, 45, 90, so I got x, x, and x square root 2. Okay, so we're going to solve just my 30, 16, 90 whoop first. So give me 1 second so I can erase my lines. Okay, so we're going to look at it from this 30-degree angle first. So if I label my sides, across from 30 is going to be my O, this is always going to be my H, and then this one's going to be my A. So let me write in my SOHCAHTOA. Okay, so it goes O then H for sine, from looking at it from your 30-degree angle. So my O stands for X, and my H stands for 2X. So if I simplified that, that's going to get me 1/2. Okay, my cosine is A then H. My A stands for x square root 3, and my H is 2x. So my x's cancel. I get square root of 3 over 2. My tangent is O then A. So my O is x, and my A is x square root 3. So that will simplify if I cancel out my x's and type in 1 square root of 3 in my calculator. It will be square root of 3 over 3, because you can't have a radical in the bottom. Okay, then we're going to look at this one for my 45, 45, 90. So this is going to be my O, my A, and my H. So if I do sine of my 45, 45, 90, it is O then H, so x over x square root 2. My x's will cancel. I type it in my calculator. I'll get square root of 2 over 2. Okay, cosine is A then H, so it's going to be the exact same thing. So square root of 2 over 2. Then my next one is O over A, so x over x, which should get me 1. Okay, if you actually type all of these in your calculator, as long as your calculator, if you press mode, you need to make sure the DEG is highlighted, so it is in degree mode since we were typing degrees in. The next time if you press sine of 60, it should pop out the correct answer for you. Cosine of 60 and tangent of 60, it will all pop out the right answer, so I'm going to just go ahead and fill in the rest of these. Okay, so now we're just going to solve using our basic trig. Okay, so first I'm looking at this one from the 60-degree angle. So I'm going to label my two given sides. We have the opposite and the hypotenuse. So I'm going to go ahead and write out my SOHCAHTOA. The one that contains O and H is going to be sine. So I do sine of my angle equals, my O stands for x, my H stands for 12. So to solve for x, we're going to multiply both sides by 12. And then you're going to type this in your calculator and round to the nearest tenth. So I got 10.4, okay? Remember, your hypotenuse should always be the longest length, so if for some reason you got something longer than 12, you might have messed up somewhere. Okay, my next one here, I'm looking at it from 30, so I have my opposite and my adjacent, which is going to be my tangent, because that contains O and A. So I do tangent of 30 equals my O, then my A. Okay, if I'm solving this, this one's a little bit trickier. Let's get the x out of the fraction. So we're going to multiply both sides by x. And then right now it's being multiplied by tangent of 30, so we can divide by tangent of 30 to get rid of it. So this time in your calculator, you're typing in 8 divided by tangent of 30. Okay, and I'm getting 13.9. All right, my next one here, we're going to look at it from 38. So I've got my opposite and my adjacent, which is going to be tangent again. So I've got tangent of 38 equals my opposite, then my adjacent. So we got to multiply both sides by x again. And divide by tangent of 38. Okay, so type in 10 divided by tangent of 38 and round to the nearest tenth. Okay, I think I'm getting 12.8. Okay, my next one here, we're looking at it from 20. So I've got my O then H. So in my SOHCAHTOA, it's going to be sine of 20 equals my O then my H. So you multiply both sides by 14.5. Okay, so this time you type in sine of 20 times 14.5, or 14.5 times sine of 20, and then round it to the nearest tenth again. I'm going to go ahead and go to the next one. Okay, finding a lot of missing things. So I know A is 80 degrees, so I'm going to fill in A is 80, and then I have B as 6. So I'm going to fill them in over here. A is 80, B is 6. My big C is 90 degrees. Okay, there are 180 degrees in a triangle, so if I add 80 plus 90, I get 170. I could take 180 minus 170, and I'll get my angle B, which is going to be 10. Okay, to find a missing side here, we're going to look at it from 80. We're going to find A first, so let's forget about C. So I'm going to label my two other sides in here, my opposite and my adjacent here. So I'm going to be using tangent of 80 equals my opposite, which is A, or you could represent it as X, and then my adjacent, which is 6. So I have to multiply both sides by 6. I'm typing in 6 tangent of 80 to figure out what that side A is. Okay, and I'm getting 34. Okay, and then we could use Pythagorean theorem to find the next one. So you would do 6 squared plus 34 squared equals C squared, because I'm missing my right angle. Opposite of squaring is square rooting. Okay, so that is what you're going to type in to be able to find that missing side. So I'm going to go ahead and fill A in for 34. Okay, and I'm getting 34.5. Okay, my next one here, we've got B is 8, C is 14. So B is 8, C is 14. So I can use Pythagorean theorem to find that missing one. So we could say 8 squared, let's keep it as A. So A squared plus 8 squared equals 14 squared. So if I wanted to solve it, we could subtract 8 squared. I get A squared equals 14 squared minus 8 squared. Opposite of squaring is square rooting, so we could type that whole thing in right there to find that missing side. And I'm getting 11.5. Okay, so A is 11.5, B is 8, and C is 14. Okay, my C is my right angle again. Okay, so to find a missing angle, we're going to have to do inverse. So let's say we pick A here. I'm going to label my two given sides. So I've got my adjacent and my hypotenuse, which is going to be cosine. So we're just going to say cosine. We're trying to find angle A, so let's just put a big A in there, equals my adjacent over my hypotenuse. So to find a missing angle, you have to do the inverse cosine of the fraction that it's equal to. So this, you press second cosine to be able to figure out what that angle measure is. And we're going to round this to the nearest degree. Okay, and I'm getting 55 degrees on my phone calculator. So 55 is then going to be A. Then we can add that, take it away from, add that plus 90. So 90 plus 55, 180 minus that 145. This is going to get me 35 left for this one. So you have to do inverse to get rid of it to find an angle. So that might be something you want to write down.